Good morning, everyone. Welcome. All right. Yes, my voice is clear to everyone. Please once confirm. Okay, very well, everyone. Chalo, let's begin our session. So, today is Friday. Usually, we have our sessions on Tuesday and Saturday only, right? So, yes, so this session is the Tuesday session that we are having today. And what are more topics that we are going to do? Today, we are going to continue aromaticity. After this, we are going to start acid and base organic. Okay, and after that we are going to do carbohydrate chemistry, followed by the amino acid. So all of these topics we are going to complete on the YouTube. Okay, and definitely we will do the practice in the battle of poles in the upcoming month. Also, we are doing battle of poles on many important topics like reaction mechanism, reactive intermediates, coordination, and many important topics like these. So if you haven't yet joined, please do. These are all free practice classes, free for everyone, every day 6 p.m. Okay, all right. Also, if you want to join me on Unacademy Plus, where I am continuing the course on spectroscopy, organic as well as inorganic, you can join me. And along with that, we are doing bio inorganic, as well as today we are going to start the main group. Okay, so in the 10:30 a.m. session, we'll start the main group elements today. All right, so do so by using any one of these following subscriptions by using the code Jagriti S. All right, chalo. Very well, everyone. Voice is clear. Now we are going to continue talking about the aromatic compounds. And in the previous session, I think we had discussed about all the important aniline system. Yes, you have seen the previous session, yes or no? We have discussed about the aniline system. Yes. So what are we going to do today? We have also talked about the Hickel's rule, right? That what is the criteria for aromaticity and how many different types of aromatic compounds are there. Today we are going to start with the Craig's rule. All right. So we start with the Craig's rule, and then we also see how many different types of aromatic compounds are possible, and then we see ki, what are the kinds of question which are being asked on this topic. What is the application of aromaticity? Okay. Yes. So first of all, guys, what does the Craig's rule say? So this rule is to determine. So we shall write to determine aromaticity, to determine aromaticity for polycyclic polycyclic non-benzenoid molecules. Okay, non-benzenoid means, and what is polycyclic? Polycyclic is more than one fused cyclic system, and non-benzenoid, which means it could be 5 membered or 7 membered or 8 membered, but it is not 6 membered like benzene. Okay, so I am talking about, let's say, this structure. First of all, start with a very simple molecule. So this is the structure that I'm talking about. All right. How would I determine whether this is anti-aromatic, non-aromatic, and so on? So according to the Craig's rule, what happens is either your molecule is aromatic or it is non-aromatic. It cannot be anti-aromatic. Okay? No, no, Shushmita, it cannot be anti-aromatic. Either it is aromatic or non-aromatic. So let's see the Craig's rules. First assumption is, yeah, first criteria is the molecule must have a C2 axis. Okay, the molecule must have a C2 axis. Okay, so first criteria is this. अगर ये fulfill होता है, then we move onwards. Otherwise, we just stop over there. So if the molecule is having a C2 axis, what do you have to see? You have to count the total number of double bonds. Okay, count total number of carbon-carbon double bond, that is given a number capital N. That is going to be capital N. Now, based on this capital N, if the value N minus 1, if the value and N minus 1, this is equals to odd number. If N minus 1 is odd, the compound is non-aromatic. If N minus 1 is even, compound is aromatic. Alright, so simple. So if N minus 1 is equals to even, your compound is going to be aromatic. If it is odd, it's going to be non-aromatic. The molecule is not going to be anti-aromatic. Please remember that. Okay. Chalo. So we tried this out on this particular molecule example number 1 that we have taken. You tell me guys, is it fulfilling any of these criteria? First of all, it must have a C2 axis. So is the C2 axis present in this molecule? Yes or no? है यहाँ पे C2 axis? Yes. Yes, first of all, yes, this is one C2 axis and not even one. It has two C2 axis. यहाँ पे एक और C2 axis है. Isn't it? Yes, it is having two C2. Chalo, we move onwards to the next criteria. Total number of double bond is equals to 1, 2, 3, 4. 4 double bonds. और हमने किया N minus 1 comes out to be 3. What does it become? Non-aromatic. It is non-aromatic based on the Craig's rule. ठीक है? Okay, very simple. Very, very simple. Chalo, we try out another example. Have you written down all of these things? Okay, then we move onwards. Yes, another simple example. So the name of this molecule is, let's say, pentylene. इसका name जो है, that is pentylene. So for example, in the exam, your name is given, the molecule is not given. That can happen, isn't it? That has happened before also. So this is pentylene. ठीक है? Now let's talk about heptylene. If I say I'm talking about heptylene, इससे क्या समझ में आता है guys? What is going to be the structure of heptylene? What could you say about it? Yes, that is, there are two seven-membered rings which are fused to each other. Yes or no? In this way? Alright, but the double bond position is a little bit incorrect. Right, once again. All the carbons have to be unsaturated. Yes, seven-membered fuse ring. In this way. Now the double bonds have to be, placed in such a way that you are not having any saturated carbon, right? So this is how you have to write. All the carbons have to be unsaturated in this way. Okay, this is correct heptylene structure. Now, what do we have, guys? Is the molecule going to have a C2 axis? Yes or no? यहाँ पे C2 axis है molecule में? Yes, there is one C2 axis on this side, one C2 axis in this way as well, just like the previous one. So we can say C2 axis is present. Now move onwards. Find out the total number of, yes, find out the total number of कार्बन कार्बन डबल बॉन्ड कितने हैं 1 2 3 4 5 6 6 total number of double bond. Now n minus 1 value comes out to be 5. ये क्या हो गया odd हो गया odd है मतलब what is this molecule aromatic or non aromatic. Yes, it is non aromatic, absolutely. It is non aromatic, the molecule. Okay, so heptadene is non aromatic. Let's talk about, this was our example number 2. Example number 3, let's see. Alright, so we talk about azulene. Why do we call it azulene? Yes, it is blue in color. Alright. Now, yes, does the azulene molecule have a C2 axis? Yes or no? Does it have a C2 axis? Yes, it does. ये देखो. Passing from this carbon to this carbon. ये रहा C2 axis. Yes, there is a C2 axis, absolutely. Good morning, guys. Good morning who are joining now. Yes, so we are doing the Craig's rule, and this is our third example. So azulene में है C2 axis. Now count the number of double bonds. 1, 2, 3, 4, 5. Capital N value is equals to 5. So N minus 1 is equals to 4. This is even. This is even. So we will say the molecule is aromatic in nature. Okay. So for the polycyclic non-benzenoid molecules, you don't follow the Huckel's rule. You have to follow the Craig's rule, which is as simple as the Huckel's rule. Yes, as simple as that. Okay, very well. Very good, Chetan. Yes. All right. Now, guys, let's talk about some systems which are also having the pi electrons. Okay, so that you don't get confused when you look at one molecule कि pi electron को include करना है कि नहीं करना है. Let's talk about that. So first of all, you have a molecule, let's say, like pyridine. How to see for the lone pairs, whether the lone pairs are going to be calculated or not. Okay, let's talk about some examples. So first of all, let's see pyridine molecule. Okay, so guys, tell me, pyridine molecule के लिए, are you going to include the lone pair into the calculation of pi electron density? Yes or no? Yes, for the pyridine molecule, are you going to say that 4n plus 2 pi electron system में lone pair use हो रहा है? No. You will only calculate the pi bonds. Why? Because this lone pair is present in the outside sp2 orbital, not taking part into resonance. Without the lone pair, you already have the electrons complete. So n की value अगर 1 ले लेते हैं, we have 4 into 1 plus 2, that is 6 pi electrons. So we already have so many pi electrons, and that is why it is already aromatic without the inclusion of the lone pair. Alright, very well. But let's look at this molecule. Let's look at this molecule over here. So now are you going to include the lone pair? Yes, now are you going to include the lone pair? Now you're going to include the lone pair. Why? Because the lone pair will do resonance into the system, and then only you are going to get the 6 pi electrons. Okay, very good. अब ये बताओ, For this molecule, is it aromatic or non-aromatic or anti-aromatic? The third one. Yes, it is aromatic because we are using the lone pair into the electron calculation. The resonance structure is going to be like this. This becomes O minus. The molecule, if I ask you, the molecule has a very high dipole moment because of the charge distribution like this, but it is going to be aromatic. Okay, and what do you say? The lone pair is also aromatic over here. Lone pair is also aromatic in both of these cases. ठीक है, very well, very nicely understood. Now let's also talk about more examples. ये देखो, to this molecule, for example, देखो, there's a nitrogen over here, right? Yes. So what about this lone pair over here with the nitrogen? Are you going to use these lone pair? The molecule is planar. This system is planar and conjugated, as you can see. So what is this molecule? Yes, absolutely. See, in this system, only look at the periphery. Periphery matlab only look at the boundary of the molecule. We say peripheral conjugation is present. Peripheral conjugation क्या होता है? That is only the pi bonds which are in the outline of the system, they are going to take part into resonance, not the lone pair. क्योंकि पेरिफेरल कॉन्जुगेशन में कितने इलेक्ट्रॉन्स हो रहे हैं गाइस? 1 2 3 4 5, 5 डबल बॉन्ड मतलब 10 पाई इलेक्ट्रॉन्स. तो 10 पाई इलेक्ट्रॉन्स की वैल्यू डेफिनेटली हुकल्स रूल फॉलो कर रही है. 4n+2 when the n value is equals to 2, you have 4 into 2 plus 2, that is 10. So it is following the Huckel's rule. It is aromatic structure. Also, peripheral conjugation is taking place. ये जो nitrogen के lone pair है ना, what do you call them? You call them non-Huckel lone pair. Non-Huckel lone pair. इसका क्या मतलब हुआ? Non-Huckel lone pair मतलब that is this lone pair is not taking part into resonance. Okay. Yes. Very nicely understood. Okay. So looking at one more example, let's see. जैसे मेरे पास ये मॉलिक्यूल है. All right. For example, I have this molecule. Okay. So looks like it is also aromatic in nature. Yes. But once again, tell me, is this central double bond? चलो थोड़ा सा बड़ा ड्रॉ करते हैं इसको. All right. Yes. Tell me about this double bond, the central double bond. Is it going to take part into resonance? This double bond. बताओ, is it going to take part into resonance? Yes or no? Yes. Is it? Is it going to be included into resonance? Let's see. देखो peripheral में कितने double bonds है? 1, 2, 3, 4, 5 and 6. So there are 6 double bonds, 6 pi bonds. मतलब कि 12 pi electron. Okay. So 12 pi electron के अंदर system क्या बनता है? This is going to be 14 pi electron. मतलब कि ये क्या हो जाना चाहिए? This should be anti-aromatic. Yes, it should be anti-aromatic. But you know what happens? This central double bond does not take part into resonance क्योंकि इससे भी क्या होगा, जो भी पेरीफेरी में होता है, राइट, वॉट एवर डबल बॉन्ड्स आर एट द पेरीफेरी, दोज आर डूइंग बेटर ओवरलैप एज कंपेयर टू द सेंट्रल वन. If let's say the ring is doing conjugation within itself, मतलब कि if you are using the central bond into resonance, उससे cross resonance हो जाएगा, cross conjugation हो जाएगा, which is making the molecule unstable, right? मतलब कि see, understand this guys, if you have a double bond in between, तो ये वाला जो डबल बॉन्ड है इसको क्या करना पड़ेगा, इट हैज टू डू रेजोनेंस ऑन दिस साइड ऑल्सो, इट हैज टू डू रेजोनेंस ऑन दिस साइड, तो उससे क्या हो जाएगा, क्रॉस in this way as well as in this way, cross resonance हो जाएगा, so molecule will become unstable. So what happens is, since it is 12 pi electron system which is anti aromatic system, it is going to become puckered, the molecule will become puckered and will tend to become non aromatic. लेकिन ये डबल बॉन्ड जो है सेंटर वाला, it is still a non huckyl double bond, it is still a non huckyl double bond because cross conjugation is not favored. Right. Let's see one more. Let's see one more example of the similar type of molecule. That is puckered मतलब वही non planar, distorted structure. See over here. Yes, what happens to this system? Once again, you have a double bond in the center. Yes, without the double bond, don't consider the double bond. Without the double bond on the periphery, you have 14 pi electrons, isn't it? 1, 2, 3, 4, 5, 6, 7 double bonds hai, so 7 into 2, 14 pi electrons. So the peripheral system is aromatic in nature. Yes. So once again we can say कि ये जो double bond है center वाला, this is going to be a non-Huckel double bond. It is not going to take part into resonance. Okay. So whichever double bond which is present in the system which is in the middle, ऐसे middle में लिखा होता है, you are going to say it is a non-Huckel double bond. Now let's talk about another kind of a system which are going to have fused rings but not exactly fused like the polycyclic aromatic compounds. अब ये देखो, ये वाले जो molecules हैं in this way, fused rings. But how is it fused? Fused with one carbon like this, one common carbon like this. Okay, ये वाले system क्या थे? They were fused with two common carbons. They were fused with two common carbons, heptadene, azulene, and so on. Now these are the fused rings with only one common carbon. Okay? Yes. Now what is it going to be? Yes. What is it going to be? Aromatic or non-aromatic? All right. Yes. Now visible. Okay. Chalo. So let's continue, guys, where we were. Right. So we were talking about this system. ये fused system है with one common carbon. Now, how are we going to know whether this is aromatic or non-aromatic or anti-aromatic? Yes. So once again, this system is going to be either aromatic or non-aromatic. ठीक है? Such type of system could be aromatic or non-aromatic, but never anti-aromatic. But it is never going to be anti-aromatic. Okay? What system? The system with fused rings with one common carbon. ठीक है? All these kind of system. तो अब अगर हम देखते हैं, yes, when I say that I can consider two possible resonance structures for this system, I'm saying I can consider two possible resonance structure for this system in which one of the ring on the left hand side, let's say it got the negative charge, the other one got the positive charge. So this system becomes anti-aromatic, isn't it? 4 pi electron system in this system becomes aromatic. Similarly, if I consider one more resonating structure in this way, then what happens? Yes, then what happens? ये देखो, this part has become aromatic and this part has become anti-aromatic. मतलब कि this molecule, when I'm separating the charges, when I am breaking this double bond, separating the charges, I will get any one of the ring to become anti-aromatic. तो इसीलिए हम क्या करेंगे? I will not open. ठीक है, I will not open this double bond. Let the molecule be as it is. और ये molecule as it is जो है, it will become non-aromatic. Does it make sense? Yes or no? You open the system like this, and if you see कि दोनों में से कोई भी ring anti-aromatic हो रही है, then we are going to say the molecule is non-aromatic. Just like this, we are not going to open any of these rings. Okay? Does it make sense? Yes or no? All right. So now we move onwards and we see more examples in this category, fused rings with one common carbon. So now we look at this kind of a system. So a question comes, इसमें क्या question आता है guys? What is the bond rotation energy या फिर order of bond rotation energy, which means कि ये जो central double bond है ना, how easily it is going to be rotated or how easily it's going to be broken so that we can rotate two of these rings. एक तो एक ये आता है और आता है energy barrier का. Okay, so let's see. Now in this molecule guys, we are trying to draw the resonating structure. Let's see. Alright, so here we know कि हमारे पास cyclopentadienyl anion as cyclopropyl cation बन सकता है. So this system is going to be aromatic in nature. Why? Because it can lead to two of these charged rings which are aromatic. तो हम कह सकते हैं that the energy barrier of rotation is very low. Energy barrier of carbon-carbon bond rotation is very low. Yes, isn't it? Because the bond could be broken easily, तो easily rotate भी कर पाएगा. Bond rotation energy is very low. Also, let's say आपको substitution दे दिया यहाँ पे. Let's say you are given substitution. This is CH3 over here and this is CH3 on this side. So I am asking you a question कि what is the energy या फिर cis trans isomerization. Cis trans isomerization is possible or not? In this molecule, is it possible? Cis trans isomerization कैसे होता है? Cis trans isomerization by breaking the double bond, rotate the ring, you are going to get the cis molecule. फिलहाल ये trans है. After rotating from this double bond, you are going to get the cis molecule. ठीक है? So cis trans isomerization is possible in this particular molecule. However, अगर मैं इसका example लूँ guys, let's say I am asking you, इसके अंदर बताओ cis trans isomerization possible है क्या? Let's say I have taken a trans molecule in this way. Is it possible in this molecule? Cis trans isomerism? Not possible. It is not possible over here. क्यों? क्यों possible नहीं है? Because the barrier of rotation is very high. Because if the double bond breaks, it is going to give you two ions, and in that case, any one of the ring will become anti-aromatic. तो ये वो करेगा ही नहीं. It is non-aromatic. Okay? So this trans isomerization not possible. ठीक है? Let's see more examples now. All right. More example. The third example that we see in this category is in this way. So I am taking a 3-membered ring and then I am taking a 7-membered ring over here. अब बताओ, what is this molecule? You tell me quickly. जल्दी से बताओ. First ring. Anti-aromatic, non-aromatic और aromatic. Anti-aromatic तो हो ही नहीं सकता. So it has to be aromatic or non-aromatic. Yes, what is it? Absolutely, this is going to become non-aromatic. Why is it non-aromatic? Because if you want to open up this bond guys, ये bond हमने open up कर दिया, let's say I have opened up this bond over here. So ये तो हो गया tropylium cation aromatic, but this has become anti-aromatic, isn't it? Yes. This ring will be anti-aromatic if you just change the charges. Then once again tropylium anion will be anti-aromatic. So in both the scenario, एक ring तो anti-aromatic रहेगी, इसलिए we don't break the double bond. That's why it's non-aromatic. यहाँ पे break करो. Is this molecule aromatic or anti-aromatic or non-aromatic? Favorable situation, isn't it? Both of the rings are aromatic. So I would say this molecule is going to exist in this form and the molecule is aromatic. और रोटेशन बैरियर फिर से लो हो जाएगा बिकॉज द बॉन्ड इज easily rotated. Also I can say the dipole moment of this molecule is very high. Why can I say that dipole moment is high? ऐसा क्यों बोल सकते हैं guys? Because this charge can actually take part into resonance and it can go far away from each other, isn't it? ये देखो, I can write a resonance structure of this molecule in this way. ये मैं यहाँ पे डबल बॉन्ड्स को मैं बहुत दूर लेके चली जाऊं अगर, the charge is if I am just writing it in this way कि ये बहुत दूर चले गए charges, then also the ring is going to be aromatic. And then what happens, the distance in between the charge increases and the dipole moment is high. So for those rings which are having the high dipole moment, they are definitely aromatic in nature, and vice versa you can say. Okay. Yes. All right guys, now let's see one more new category of the system, that is quasi aromatic compounds. देखते हैं guys, थोड़ी सी classification और है. Yes, this is done I guess. So within the same classification we are going to complete everything. What is a quasi aromatic system? The one that we have already been studying. Quasi क्या होता है? Quasi is almost aromatic, not exactly aromatic but yes almost aromatic होता है quasi. So अगर ये molecule है, देखो, in this molecule over here, if I am providing some kind of an electrophile, let's say, what is going to happen? Let's say I've provided a proton. Okay, what's going to happen? It is going to give OH and यहाँ positive charge. So this system becomes aromatic. It is stable. Yes, ये हो गया क्वासी एरोमेटिक, मतलब कि ऑलमोस्ट एरोमेटिक. तो हम कैसे बना सकते हैं ऑलमोस्ट एरोमेटिक कंपाउंड? बाय फॉर्मिंग आयंस. सो आयनिक एरोमेटिक कंपाउंड्स. Ionic aromatic compounds. Okay. Yes, what is next? In this way I'm providing a very strong acid to this molecule. What is it going to result into? It is once again going to result into a tropylium cation. Yes, it's going to result into a tropylium cation. All right, very well. Similarly, एक और reaction देखो guys. Let's say somehow I have one fluorine over here. तो मैं अगर इस molecule को antimony pentafluoride से if I'm reacting this molecule, what do I get? I will get the cyclopropyl cation plus antimony hexafluoride anion, like this, isn't it? Yes, तो ये हो गए हमारे quasi aromatic compounds, the ones which are forming ions and then they become aromatic after forming ions. Okay. Yes, very good. So guys, please remember the ionic aromatic compounds are quasi-aromatic compounds. One more category remains, that is your homoaromatic compounds. Have you heard about this? सबने सुना है homoaromatic, सबको पता है, isn't it? Yes, you have heard about homoaromatic compounds. Yes. All right, very very good. So the compound which has conjugation over all the molecule but एक या दो कार्बन saturated हो जाएंगे, मतलब कि a compound, yes, a compound having one or more sp3 hybridized carbon atoms. Okay. Okay, all right. So these kind of molecules having one or more than one sp3 hybridized carbon atom, ये क्या करेंगे? Definitely the rest of the molecule which can do the delocalization, that is going to become aromatic, but only this part will be anti-aromatic. जैसे कि this is a very common example which is given all the times, cyclooctatetraene. हमेशा आता है ये. Yes, हो सकता है योगेश. Yes, we are going to discuss that. So bridged 10 annuline also we are going to discuss after this one. See what is this? Cyclooctatetraene, guys. वैसे देखा जाए तो this molecule is anti-aromatic. Yes or no? This molecule, this is anti-aromatic in nature, isn't it? Yes. तो अगर ये anti-aromatic है, what can we do about it? We can add sulfuric acid to it. Let's see what happens. Sulfuric acid क्या करेगा? There is going to be H plus. One of the pi bond is going to attack the H plus, and then I'm writing normally over here. What happens is one of the carbon is going to get the proton, is going to attack from the pi electron density, and one of the carbon has a positive charge. So how is the molecule going to be written, guys? ये देखो, ये molecule ना थोड़ा ऐसे लिखा जाएगा now. In this way. There is a positive charge, alright, and this is your hydrogen over here. Yes, 1, 2, 3, 4, 5, 6, and 7. Okay, and this is the eighth carbon. So what happens is in this way you can say, ये हो गया homoaromatic, because the resonance is taking place only in this region from this carbon to this carbon. Since it is a positive charge, vacuum p orbital है, resonance तो हो ही सकता है. So it is homoaromatic. Only within this region the resonance is taking place. ये वाला carbon sp3 है. Okay, no resonance over here. So it is going to be homoaromatic system. Along with that, guys, there is one more system. ये देखो, मैंने पहले आपको बताया था, right? 10 annuline system has the hydrogen repulsion. So that's why it does not want to become planar. लेकिन अगर 10 annuline system में somehow if we replace both of the hydrogens which are causing repulsion by CH2, अगर उसको CH2 से replace कर दिया है, then the system will hold planar. The system is planar now. और ऊपर वाला जो carbon है, this is not going to take part into resonance, but it is holding the molecule together, it is making it planar. So the system is ultimately going to be homoaromatic. Okay? Yes. ये आ गया आपका बहुत simple सा example. Now, what is the stability order, guys? Stability order कैसा होता है? Aromatic compound is definitely the most stable. Definitely the most stable one. Aromatic आया, फिर homoaromatic आया. Then there is non-aromatic. Then finally, you have the anti-aromatic system. Okay. So this is the order of stability for your aromatic, homoaromatic, non and anti-aromatic. ये इस तरीके से follow करें. Now guys, let's see some questions. That what are the types of questions which are asked? The thing is understood to everyone. Yes, let's see. Question number 1 is, which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? Which of the following compound is the most stable? नहीं चेतन, क्वासी नहीं आएगा। क्वासी इज एरोमेटिक ओनली, क्वासी एरोमेटिक ही है, जस्ट दैट वो आयनिक एरोमेटिक है। So, which of the following compound shows geometrical isomerism? Let's say first one I'm writing, there's a hydrogen, there's a CH3, there's a Cl, and there's a I over here. Second one, okay, it's just a single bond only, alright? Okay, out of these three, हाँ yes चेतन वही हो गया है, but yes, this is only a single bond. Let's erase this then, overwriting low. Now okay, 1, 2 and 3. Which of them shows geometric isomerism? Answer is quickly. We'll do one more question after this. Which of the following compound shows geometrical isomerism? अब देखो, every definitely you have a double bond. Everyone can show a geometrical isomerism, but the question is based on the rotation through the double bond. मतलब कि ये जो double bond है इसी के through rotation करके. So if you see option number 2, the rotation barrier is the least, isn't it? Least rotation barrier in this one. So definitely 2 is going to be the correct answer. Yes. बाकी सब में rotation barrier high है. That is the question simply. This is aromatic system. Okay. Chalo, let's do one more question before going on. ठीक है. Match the following है. There is column A and column B. So positive, positive. B over here is the same molecule, although negative and negative. C is cyclobutane. Alright, this is negative over here. D is negative and positive in this way. Option number A. The option number 1 is aromatic. Option number 2 is anti-aromatic. Option number 3 is non-aromatic. 4n plus 2 pi electrons. Alright, so the options goes like these. First option क्या है? A matches with 1 and 4. B matches with 1 and 4. Okay. C matches with 3. D matches with 2. मतलब कि A could match with 1 and 4. B could match with 1 and 4. C could match with 3. D could match with 2. B option is A could match with 1 and 3. B could match with 1 and 2. C could match with 3 and D. Alright. So what is the correct answer? Yes, so out of all of these, what is the correct choice? What is the number of pi electron in option number A? Option number A क्या होगा guys? There are 2 pi electron system over here. So when you put in the 4n plus 2 system, when you put n is equals to 0, you have 2 pi electrons. That is aromatic. When n is equals to 1, you have 6 pi electron system. That is also aromatic. तो ये 2 pi है, ये 6 pi electrons है, ये क्या है? 4 pi electrons, but conjugation is not present. This is a saturated carbon, hydrogen, hydrogen. This is 4 pi electron system. तो D को हम बोलेंगे anti-aromatic. D is going to match with 2. C is going to match with 3 because एक carbon saturated है, non-aromatic हुआ. 2 and 6, sorry, 1 and 6, 2 and 6 pi electron, that is A and B. They are going to be aromatic also as well as following the Huckel rule also. तो ये भी सही है और ये भी सही है, 1 and 4. Both of these are going to show correct to 1 and 4. और last में C is going to be 3, D. Okay, I hope it makes sense. More than one option is correct. ये उस type का MCQ है. Also the options are given to you. You should not be confused. Alright guys. So I hope that you have understood plenty of stuff from here. Now tomorrow also on the same time we have another session. ठीक है? So कल हमारा फिर से 9 बजे एक session है. Alright, and we are going to continue the series of aromaticity, acid base, carbohydrate, and so on. Alright, so now I'm going to see you all at 10:30 in the Unacademy Plus session on main group elements. And bye everyone and have a nice day all of you. Take care of yourself.